So on that, was or were there, if we were to get a little more specific, a key problem, a key person, a key mathematical topic, or we've already talked about factorials, that really cemented the idea that math and math education is what you wanted to pursue?
Um, I don't know if there was ever anything so specific as that where it's like, one moment, and before that moment, I was like, I don't know about math education. After I was into it, I think like I sort of enjoyed it just ambiently for a while. I mean, I will say there was a very influential calculus teacher I had who I had he basically taught at my school for like 2 years, and I was lucky enough that like the 2 years I had calculus happened to be when he was there. And he was one of these who like sort of made an effort to try to show students what was beyond just like in the class itself. So of note is that he would also like make sure that in his schedule, whatever the most like remedial math class in the school was, like he would make sure that he was teaching that. But then he also really liked to teach sort of the more advanced ones for the kids that were like into academics. So he liked to sort of straddle both of those ends. Um, and because I was, kind of nerdy and I enjoyed the subject, I would often just like maybe ask him some more questions after class. And then because he was clearly amenable to that, I would like ask some more and more. And he would just like share these things where uh, you just kind of think of it as such a linear thing in school at first. It's like, oh, you take like algebra one, then algebra two, and then geometry. And it's like there's this line. And maybe that was the first moment where he starts talking about all this other stuff that makes it feel like this tree with a bunch of branching. And he told me about like other places that I could go to learn more about things. So there was this group at the University of Utah, like that. It was a math circles event. I don't know if anyone here is familiar with math circles and the like, but so I certainly had been like unfamiliar with that. I was like, oh, cool. There's just like I guess some other kids around my age will like come and we just learn about totally random seeming bits of math. And because it was at the University of Utah, there was actual like mathematicians who would talk rather than just like math teacher. And I think maybe that was the first time that it was clear that mathematician was a thing. That there's people who just like do math as a living, not in the sense of like in the service of engineering or something, but that somehow that was a career in and of itself. And so for me, that maybe that was this moment like, oh wow, maybe I kind of want to do something in that vein. Um, and there was definitely lots of problems in that like seminar that sort of stuck out. Like uh, I'm gonna flub on like the exact specifics, but I remember like one lesson about using roots of unity in the complex plane to solve like geometry questions, where let's say you have I give you some kind of pentagon, and it's inscribed in a circle with a radius of one, and then I ask you, you could ask various geometry questions like, hey, what's the side length of that pentagon, or what's the length of the diagonal, or something like that, and uh, one I think the phrasing of the question was like if you look at the two diagonals of this pentagon, uh, and you multiply their lengths together, and then you also multiply that by uh, well, let's just say we take one diagonal and we multiply it by the length of one of the sides. Like, what is that value? And you might think to do that, you have to find like both the side length and the diagonal, and that's going to involve some like weird trigonometry, and maybe you need to know like the sine of 72 degrees off your head or something like that. But there's just a completely beautiful way of thinking about it if you think of those numbers as being the roots of the polynomial z to the fifth minus one. Um, and then if you uh, factor that polynomial, you can write it down as z minus 1 times z to the fourth plus z cubed plus z squared plus z plus 1. Like any of these polynomials that look like z to some power minus 1, you can always factor out because you know one of the roots is 1. And then the rest of the roots exist somewhere in this other polynomial that's just got nothing but coefficients 1. And so then if you ask something like, hey, what happens if you take this polynomial, and in the factored form, it looks like z minus one of the roots times z minus another one of the roots, on, and you ask what happens when you plug in a number like 1. Well, when you look at it in terms of the coefficients, you can just see what it should be when you plug in 1, because all the z to the some power terms are just going to be equal to 1. Whereas if you look at it in the factored form, it gives you this very non-obvious fact about like a product of a bunch of complex numbers that if you try to try them out, it's basically the like geometric lengths associated with the pentagon. So you can kind of get clever and directly get at the answer to this, what's the product of those two values, which of course was a question contrived so that you could use this cleverness. But that connection, I mean, that was just sort of like this mind-blowing thing. Like, oh, wow, okay, you've got this connection between like geometry and algebra and whatnot. And it came up in this math circles event that, very unlikely you're going to see that in a high school class, but the fact that it was something that was separated out just for the sake of just like teaching high school kids things that are at their level that they don't otherwise come up. Uh, I think some accumulation of those made an impact such that by the time I was going into college, like it was pretty clear I wanted to major in math. And even if I didn't know exactly what path, like should I be a research mathematician, or something else, like some life path that included that was going to be part of it. But math communication, I mean, that it's not wasn't really, and kind of still isn't really like a clear career path in and of itself. Like usually it's like in the service of something else, or like you're a research mathematician and you happen to engage a lot of outreach or something. So I don't think I would have had any way of like any moment to click into what I'm doing now, except for when I like stepped back and realized I was already doing it sometime.